Hello everyone, today let's solve the problem 2 out of 3. So this was asked on Yandex.Algorithm, this one, 2011 qualification stage 2, this one, right? So you can just go through the question, it's easier to understand. I'll just summarize so that it will be easier for us to solve the problem, right? So just give me a second, 1 second here. Yep. Yeah. Now what the question states here, there are n people in the queue. Just remember one thing, there are n people in the queue, right? So person I needs this one, a to the power of a of I time, basically. Sorry, just solving some problems on the number theory. This is fine, man. There are n people in the queue, person I needs a of I time. Just remember this. The second point here is the cashier can serve two people simultaneously. The cashier can serve two people simultaneously. S is nothing but simultaneously. And serving two with times x comma y takes max of x comma y. So this is very important, right? Serving two people simultaneously with times x comma y takes max of x comma y. Just remember this one, this is very important, right? So there are n people in queue, person I needs a of I time. The cashier can serve two people simultaneously, and serving two with the times x comma y takes max of x comma y. So the third one here is at each phase while greater than or equal to 2 people remain, right? At each phase Vasya chooses two people among the first three, right? At each phase Vasya chooses two people among the first three in queue to serve simultaneously, right? So if one person is left at the end, they go alone. This is fine, I believe this is fine, man. At each phase Vasya chooses two people among the first three in the queue to serve simultaneously. Again, Vasya chooses two people among the first three in the queue to serve simultaneously. If one person is left at the end, they go alone. If one person is left at the end, they go alone. What we need to do then, we have to output the minimum total time using this rule and concrete pairing sequence as well, right? So both the things we have to output here. We have to output the minimum total time using this particular rule, and we have to output the concrete pairing sequence as well along with the minimum total time. So this is the question basically, right? I hope this is clear, man. See, let me read the question loud again. So just listen to this carefully, then we'll move with the this one, other stuff, right? So there are n people in the queue. So this one, person I needs a of I time, right? So the cashier can serve two people simultaneously, and serving two with times x comma y takes max of x comma y, right? This part. At each phase, while greater than or equal to 2 people remain, Vasya chooses two people among the first three in the queue to serve simultaneously. If one person is left at the end, they go alone, right? So what we need to do, we have to output the minimum total time using this particular rule and concrete pairing sequence, right? So these two we have to, right? These two things we need to this one display, right? So output the minimum total time using this particular rule and concrete pairing sequence, right? So these two things we have to output. So this is fine, I believe. So this is the question. See here, we have been given the input 4, nothing but the n, and array 1 2 3 4. So the minimum total time here is 6, and this one, the concrete pairing sequence here is 1 2 and 3 4, right? So same goes with the input 2 or the example 2 as well, right? So I hope the input output part is completely clear here along with the question. Now as we are completely familiar with the question, let's do one thing. Let's quickly discuss this one, approach followed by the complexities, and then let's write the code. As usual, let's discuss the approach. So now I have considered the same first example that they have given in the question here, right? So this is n and this is nothing but the array a, right? So this is fine. So output that we need to get here is 6 along with 1 2 3 4. So one thing I want to tell you here is we'll be making use of the dynamic programming, right, to solve this particular problem. So let's move on with the step-by-step explanation. So I have considered the same first example for the this one approach basically, right? So first thing is phase choices. right? So from the front three, first from the first three people, the Vasya will be considering the two people simultaneously, right? And one will be left alone basically. That's what I have said in the question. So let's go with the phase choices here. From the front three, so nothing but first three, this one 2 3, we can pair 1 2 1 3 and 2 3, right? So we can pair, we have to pair in two, right? So in two elements basically, this one can be 1 2, either 1 3 or 2 3. So these are the three pairs, right? So this is fine, easy to understand, right? Let's move on with the first point here. Let's consider for the 1 2 first. For the 1 2, time max is nothing but, so we'll be going with a max of 1 comma 2, nothing but here 2, right? So remaining q becomes 3 4 here, right? So for the 1 2 time, this one max of 1 2 will be considering nothing but the 2, remaining q becomes 3 4. So the next phase is this one. Next phase is nothing but out of 3 comma 4 will be considering max of 3 comma 4 is 4 basically. So here we got 2 and here we got 4, right? So total will be going with 2 plus 4 here, right? So total is nothing but 6. For the first one we got total 6 here, right? So this is fine. Next we'll be going with 1 comma 3. Again the max of 1 comma 3 here is 3, we got 3 here. Remaining q becomes 2 comma 4, remaining q becomes 2 comma 4 here, right? So the next phase will be going with here as the remaining phase is 2 comma 4, max of 2 comma 4 is again 4, right? So we'll be going with 3 plus 4 here. This time we'll get the this one total nothing but 7, 6 and 7 we got here. Next we'll be going with the 2 comma 3, the last one basically. So the remaining q becomes 1 comma 4 here. 2 comma 3 we have considered, max is 3, among 2 and 3 max is 3, and remaining q becomes 1 comma 4, again max of 1 comma 4 is nothing but the 4 here. We'll be going with the 3 plus 4 again, so this one will be 7 basically, right? So this is fine, I believe. Yeah, this is fine. Now minimum is 6 here. So we got here, see, 6 7 and 7, right? So 6 for the first one we got basically 6, for the second one we got total 7, and for the third one we got total 7. So the minimum is 6 with the pairing first one we need to consider here. For the pairing 1 comma 2 minimum, the total that we got here is 6, this one. So we have to consider 1 comma 2 basically, right? So minimum is 6 with the pairing 1 comma 2 and 3 comma 4. So remaining this one, remaining we have considered here 3 comma 4, right? So we have to go with 1 comma 2 and 3 comma 4 basically, right? So the minimum that we got here is 6 with 1 comma 2 with the pairing 1 comma 2 and 3 comma 4. For the remaining we considered 3 comma 4, right? So the DP basically dynamic program in the code will explore these possibilities and picks the optimal path basically, right? So this one is 1 comma 2 and 3 comma 4. So this itself will be displaying in the form of output. So min is 6 and the path that we got here is 1 comma 2 and 3 comma 4, right? So this one will display this one as the output, right? So the output that we got here is 6 1 2 3 4, which is equivalent to the output that they have mentioned for the example 1 within the question, 6 1 2 and 3 4, right? So our approach works absolutely correct here. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would lead to big O of m into n, which is almost equivalent to this one, big O of n square basically, right? In the worst case it would lead to big O of n square. Just remember this one, right? In the worst case, because that will be considering the DP basically dynamic programming, the DP loops over m phases and up to 2 into I states per phase bounded by the n. So overall time complexity would lead to big O of n square or n square. Yeah, the space complexity is big O of m into n, which is equivalent to big O of n square as well here in this case, right? So for the DP and pre-tables basically, we'll be going with the DP as well as the pre-tables, right? Plus big O of 1 for the arrays. That one also will be constrained. So it is equivalent to the big O of n square as well. So the time and the space complexity for the code that we'll be writing in the future would be big O of n square, we can consider, right? So this is fine, man. Now as we are completely familiar with the complexities and the approach, we are good to write the code. Let's start writing the. So we'll be making use of the fast input and output. So I'll just import input output package, right? So I'll just go with Java io start. This is fine. Also we'll be making use of the different utilities, so I'll just import the utility package as well. So I'll just go with util.start. So we have to make use of the class, right? So I'll just go with the class main as usual. So you can just give any class name that's relevant to the question, right? So first we'll be going with the node, basically the node that stores the pair x comma y, right, chosen at some phase and the previous state. So let's go with the node. So I'll just go with the static here, class node. So within this let's go with the initialization part. X is nothing but the first index and pair, y is nothing but the second index and pair, right? So I'll just go with, we have to go with the p as well, I believe. So let's go with here int x comma y comma p. So this is fine, man. Next let me go with the node constructor part or the initialization part. So this one will be I need the parameters x, y and p. Int sorry y int p, right? So this is fine. Let's initialize this one quickly. This dot x equals x, this dot y equals y. Also we need to initialize p as well, right? So this one, this dot p equals p, right? So this is fine. We are done with the initialization of the constructor part. Next let's do one thing, let's go with the main method, right? So I'll just go with main method here. So let me include throws and this one as well, exception as well, or else we'll be getting the error. So this is fine, man. Next let's move on with the input output part. So let me go with buffered reader here, pr equals new buffered reader. So new input stream reader, let me give system dot n. So this is fine. Also let's go with a print writer here. So this one is fine, new print writer system dot out. So this is also fine, man. Next let's go with n, nothing but we have to read the number of people here. So this one is n equals integer dot %. So basically n is nothing but the integer. In our example n was given 4, right? N4, then the array a is nothing but 1 2 3 4. We considered the first example I'm speaking of. So this one has to be buffered reader dot read line. This is fine, man. We are just reading the number of people here, and we will be going with the array a. We have to read array a as well, right? So I'll just give here int this one a equals new int of I'll just go with n plus 5 here. This is fine. This is nothing but the times array, right? So this is nothing but the times array with extra buffer, right? So to avoid the bounds. Next let's go with the string tokenizer. So we have to read the a of I line as well. So for that one we'll be going with the tokenizer, basically string tokenizer in simple terms. So let me go with tokenizer here, string tokenizer. So st equals new string tokenizer of buffered reader dot read line. This is fine, man. Next step is let me go with a for loop. This one here we are going with a one based fill here, right? So this one will be int I equals 1, I less than or equal to n, I plus plus, right? So this one a of I, so this is equivalent to integer dot %. So this is fine. String tokenizer dot next token. So this is fine. Yep, this is fine, man. So this is one based fill, right? So this is fine. The next step would be, let's go with a simple if condition here. If n equals 1, so let me go with out dot println of this one a of 1. So this is fine, a of 1, right? So this if condition is nothing but this is for the trivial case, if there exists only one customer. So the total time will be just a of 1, right? So also we have to go with a single served person index, right? So I'll just go with here out dot flush. Let me flush before flushing I have to said something and I did something. So this one I have to go with a single served person index. So I'll just go with out dot println of this one person index, nothing but 1 here. So this is fine. Out dot flush I have already given, so we have to exit, so I'll just give a return here. Alright, so we don't have to return anything. So the next step would be we'll be going with a this one again, one more trivial case, nothing but for the 2 customers, right? When n equals 2, so then we'll be considering the total time, that is max of a1 comma a2. That is how we calculated, right? If you remember the approach. So this one will be out dot println. So this one will be math dot max of a of 1 comma a of 2. So this is fine. So this is total time, that is max of a1 comma a2. So next I'll go with the out dot println. So this is fine. 1 2 yep, we are serving them together here. Then again the same thing, out dot flush here, and we have to return. So we don't have to return anything, we have to exit here. So I'll just give return. So this is fine, man. So let me come out of this one entirely. Now let's come to the main part here. We have to go with the number of phases, nothing but ceil of n by 2 here, right? Also we have to go with a large value for the initialization. These 2 things we have to do. First let's go with the number of phases, nothing but int m equals n plus this one n plus 1 by 2. This is fine. Also int infinity, so this is equivalent to, so int of this one 1e9. So this is fine. Yep. Now let's go with the dp of ij, man. Minimum total time after I phases such that the certain pointer or state is j. Also we have to go with a, I'll be going with a pre of ij that stores the node describing the pair that is used at the phase I and previous j. This one, so we'll just go with the initialization first, then we'll be making use of it as I have said this one, right? So this one, let's go with a, let's initialize the dp array here. So this will be dp equals new int of, I'll just go with m plus 1 and n plus 5. So this is fine, man. Also let me go with node here. So this one will be pre, I'll just go with this one new node of, this one is also same thing, man. Size m plus 1 and this one will be n plus 5. This is fine. The pointer table for reconstructing the answer. So let's initialize all the dp cells to infinity. So this one will be for int row of this one, what do we call, dp, right? So this one will be arrays dot fill for row comma infinity, right? So this is fine, man. We have initialized all the dp cells to infinity, right? So next let's go with the this one base case. After the first phase I equals 1, we can pair any 2 among the first 3 customers, right? So either we can go with the dp of 1 1 1 2 and 1 3, right? So we can pair from the example, if you remember, we went with the pair 1 2 1 3 or the 2 3, if you remember, right? So let's go with the base case. So let me write this one very quickly. So this one will be dp of 1 1 first, this one will be math dot max of a of 2 of comma a of 3 as well, and also let me go with pre of this one 1 1, this is equals to new node of 2 comma 3 comma 0. This is fine. So same goes with dp of 1 2 and dp of 1 3 as well. So let me copy this one. So this is also fine. So this one is nothing but dp of 1 2. This is fine. This one is a of 1 3 we have to consider, right? So this one has to be a of 1 3. This is fine. And pre of 1 2, this is fine. New node of 130, this is fine, right? New node of 130, pair 1 comma 3 we have considered, and pair 1 comma 2 also will be considering here. So dp of 1 3, let me consider 1 3, mat dot max of a of 1 a of 2, this one a of 1 a of 2, this is also fine. Let me go with a of 2, this one will be pre of same as dp, right? So this one will be pre of 1 3. New node of, instead of this one we'll be going with a 1 2 0, right? So we have considered a mat dot max of a of 1 and a of 2, right? So new node of 1 2 0, this has to be 1 2 0, 2 3 0 1 3 0 and 1 2 0, right? So we are just pairing 2 comma 3, this one pairing 1 comma 3 and pairing 1 comma 2 respectively, right? So this is fine, man. Now what we need to do, we have to build the dp for the phase I equals 2 to m, right? So in simple terms, let's move on with the iteration part. So this one will be int I equals 2, I less than or equal to m. So this one will be I plus plus, within the for loop. So for each possible previous pointer j that could exist up to 1 to 2 into I minus 1, this one we have discussed in the approach. So I'll just go with one more for loop here. This one will be int j equals 1, j less than 2 into I, j less than 2 into I, and finally so this one will be j plus plus, this is also fine. So within the for loop what we'll be doing, so let's go with the option 1, option 2 and option 3, right? So this is fine, just give me a second here. Yeah, our option 1 was we have to pair the new 2 positions, right? So 2 into I and also 2 into I plus 1. Now basically we have to leave the j unchanged, right? So the same thing, let's do the same thing, similar thing for the option 2 and option 3. First let's go with the option 1 here, as I've said. So this one will be if dp of ij, so this one if it is greater than dp of I minus 1 j, this is fine, plus mat dot max of what we need to consider, first a of 2 into I, this is fine. Also we have to go with the a of 2 into I plus 1, right? Accordingly what we have discussed basically. This one will be a of 2 into I plus 1, this is also fine. Yep, 2 into I plus 1, right? So this one would be so within the if condition, we have to update the cost basically. This one will be dp of ij will be dp of I minus 1, where we have to update the cost, meaning here this one will be j itself. Yep, this is fine. Again let me go with, yep, mat dot max of, so again we have to consider the same thing, man. So I'll just copy paste the same thing over here. Let me copy this one. This one has to be 2 into I plus 1. Wait 1 second. Yep. This is fine. Yep, until here. Of 2 into I, this one 2 into I plus 1, this is fine. We are just updating the cost here. So this is fine, I believe. Next step is we have to store the chosen pair and also the previous j, right? So this one has to be pre basically. Previous j, this one also we have to, right? So this one has to be previous ij, new node of 2 into I basically, comma, same thing again, 2 into I plus 1 along with the previous j. I said we are storing previous j as well, so I'm considering j here. So this is fine, man. Now we are done with the option 1. We have to go with the option 2 basically. Let me copy this one entirely, right? So this will be handy basically. So now option 1 was basically we were pairing the new 2 positions, nothing but 2 into I comma 2 into I plus 1. Also we left the j unchanged. In the last step we stored the chosen pair and the previous j as well, right? So let's go with the option 2 now. Let me copy paste the same thing. Here we'll be pairing the earliest pointer person j with the later index, right? Nothing but 2 into I plus 1. So let's make the necessary changes here. So this one dp of I into, instead of j I'll be going with 2 into I. This is fine. If it is greater than dp of I minus 1 into j plus math.max of, so this one will be a of j basically, right? A of j comma this one 2 into I plus 1 remains same. This one is fine. So the second line here would be dp of I instead of I into j, so this one will be dp of 2 into I again. So this one will be dp of I minus 1 remains same, j this remains same, math dot max of, so this one a of, same thing here, I have to make this a of j comma f 2 into I plus 1, this remains same. We are just updating the dp here, right? So the final step is again, so we have to store the pair j comma 2 into I plus 1, right, along with the previous j. So this one again, instead of the j, in the place of j we'll be making use of 2 into I basically, right? So previous of I into this one 2 into I equals new node of instead of again this one, what do we call, 2 into I will be making use of j. In the place of 2 into I will be making use of j. That's the main thing here. This remains same, 2 into I plus 1 comma j. This is fine. Let me come out of this one entirely. Now we are done with the option 2, right? So let me copy paste the same thing. So now we have to go with the option 3, nothing but we have to pair the earliest pointer person j with the other new index, nothing but the 2 into I. So here this time it would be let me copy paste this one basically 2 into I plus 1 because we are pairing the earlier pointer person j with the other new index, right? So let me copy this one. So in the place of j, let me give here 2 into I plus 1, right? So if it is greater than dp of I minus 1 and j, so this remains same. So this will be math dot max of a of j. So this one has to be a of j, that's it. And this one has to be, instead of we are considering for the 2 into I plus 1 itself, this one has to be 2 into I. The same thing goes here as well, man. So for the j we will be considering 2 into I plus 1 basically, right? So this one will be dp of I minus 1 j remains same plus math dot max of a of this one instead of this one, so this one will be a of j, this is fine, comma a of 2 into I. So this one let me remove plus 1 again. The final one is we have to store the pair j comma 2 into I this time with the previous j, right, as usual. So this one will be previous of I again. So this one instead of the j, let me paste 2 into I plus 1 here, right? So new node of so this one has to be in the place of 2 into I, will be replacing this one by j. Also we are considering for 2 into I plus 1 itself, so we'll be going with the 2 into I basically comma j. So this is it for the option 3. This is the change, right? So this is fine. Let me come out of this one entirely. We are done with the 3 options, right? So now the final answer is stored in the dp of m into n plus 1, right? So basically when I say m into n plus 1, you would have known the n, but n plus 1, what is n plus 1? N plus 1 is used as the sentinel or the basically end state here, right? So this one I'll just go with out dot println. So this one will be dp of m into n plus 1. So this is fine. So next let's move on with the iterative backtracking, right? So so this one I'll type fast. So this one is nothing but the iterative backtracking using the previous array, right? Just to reconstruct the chosen pairs from the last phase to the this one, last phase to the first, I believe. Yeah, this is fine. Now let's write this one very quickly. First I'll be going with the dequeue here. So let me give string, this is fine. The path variable name, let me go with, let's create the instance of the array dequeue basically. So this one will be dequeue, right? So just the syntax part, yep, we are making use of the stack here, just stack behavior to the reverse order, right? So this is fine, man. Now let's do one thing. Let's move on with the initialization part. Let me initialize I to m, j to this one, n plus 1. So let's start from the last phase in the end state index, right? So let's move on with the while loop here. So this one will be while I greater than 0 and j greater than 0. This is fine. Within the while loop, what we need to do here, so we have to go with a node describing the pair at the phase I, right? So I'll just go with a node nd equals, so this one will be pre of I j. This is fine, man. So if node is equivalent to the null, then we have to stop and exit, right? So I'll just give break here. This is fine, right? So nothing but in simple terms, we are going with a safety check, right? So this is fine. Next, let's go with the indices of the pair from this particular node. So I'll just go with int x equals nd. So this is also fine, nd dot x. Also y equals node dot y or nd dot y. So this is fine. Now let's keep the pair indices ordered, nothing but the smaller one first, right? So we are going with the smaller one first for the neat output, right? So this is fine. So how can I write this one in the form of code, man? Just give me a second here. So here I can just write it on this way, I believe. If x is greater than y, then so let me go with int t equals x, x equals y, also y equals t. So this is fine, I believe, right? So this is fine, and let me come out of this one entirely. Let me go with one more this one if condition, because if both the indices are real persons, then we have to push xy, right? So here if y is less than or equal to n, then let me go with path dot push. This is fine. X, let me go with a space here plus y. So this is fine, man. So else what we need to do, else if y is greater than n, that means the pair uses the sentinel, and at that part only x is the real person, meaning single, right? So we have to consider only x is only the real person, single here. So this is fine. So how can we write that one in the form of code? So this one will be path dot push. Let me go with the string here, dot value of x. So this is fine, I believe. Yep. So now let's move to the previous state, nothing but j equals node dot p, and also finally let me decrement the I, nothing but the previous phase. So this is fine. Let me come out of this one entirely. So this one we have to print the pairs in the forward order. So I'll just go with here while not of path dot is empty, then let me go with out dot println. So we have to print the pairs in the forward order, right? So we have to go with a pop here in simple terms. So this will be path dot pop basically. I hope this works, man. Let's see. I have made use of the pop. Let's see. Finally we are done with the code. We just have to flush the output. So I can just go with the output flush or close. I'll just go with the flush itself. This is fine. Yep, somewhere I have done something wrong, man. So what is the wrong thing I have done? I don't know. Somewhere I have done something wrong. So this is fine. 1 second. Yep, let's do one thing. Let's before this one checking the code with the different inputs, let me copy paste the signature starter template. So this is it for the code basically. Let me paste the this one. This is fine. Let me come here. Let me copy this one. We have to get the output 6 1 2 3 4, right? So let's check the same thing here. So yeah, this has to be system dot out. I have given comma here. Line number 33, this is fine. Yep, let me run this one again. Br, oh yeah, this one, br dot read line, buffer data dot read line. So r has to be small here. 1 second, the line number 35 here, this one, let me remove this one man. So this is fine. Now main method not found in the class main, please define the main method. This one, I have done something wrong with the braces actually. Damn. I realized that one, but I don't know where I have done wrong. Let me check this one, just give me a second here. Yeah man, so this is the problem. This one I do it many times actually. I have considered the node here, so this one I have to close this one actually, this bracket here itself. Let me cut this one, the last one. So let me close the node. So here, so this one JVM doesn't consider at all this one, so this main method will not run at all. So this one was within the node actually, the main method was within the this one node class, right? So obviously the code will not run. So now it has to run. Let's see. Yeah, now we are getting the correct output, 61234. So this one had to close the this one flower bracket here itself, right? Rather than I close this one at the end. Basically this whole code was within the node class, so this would not run. Quite obviously this would not run, right? So this is fine man. Now let's go with the second input. So let me copy this one. The output that I need to get here is 813254, right? So this is fine. 813254. Yep, this is fine man, we have got the correct output, right? So let me copy this one entirely. Let me come here, let me hit the submit button. Let's wait for some time. Let me paste the code, let me hit the submit. So let's wait for some time man. I hope this works for all the test cases. Let's see. So here, yep, it's running. Yep, in the toast it is showing accepted, right? So the verdict that we got here is accepted. So here we went with a pure DP to solve this particular problem man. So I have explained this one step by step. Also we have discussed the approach, so I'll not be explaining this one again. So we have made use of the pure DP to solve this particular problem, right? So I hope the solution part is completely clear, along with the approach and the complexities. For now, this is it. Thanks for watching guys.